Hello friends! In this video, we will discuss how we can use the standard deviation to determine what percentage of the values in a normal distribution fall between two numbers using the empirical rule. The empirical rule requires a normal distribution, so let's briefly describe what that means. A normal distribution is a distribution that is symmetric about the mean and bell-shaped and looks something like this. Higher parts of the graph represent more frequent observations, so most of the observations fall towards the center of the dataset, which is where the mean is, with less and less values as you venture farther away from the mean. Here's what the empirical rule tells us about normal distributions. Approximately 68% of the data falls within one standard deviation of the mean, approximately 95% of the data falls within two standard deviations of the mean, and approximately 99.7% of the data falls within three standard deviations of the mean. The empirical rule is oftentimes called the 68, 95, 99.7 rule due to these percentages, and it isn't a bad idea to memorize those numbers. Here's what the empirical rule looks like on a graph. The mean mu falls in the middle of the distribution. When we go out one standard deviation in both directions, we encompass 68% of the data. Two standard deviations is 95% of the data, and three standard deviations is 99.7% of the data. A very simple example for you to see how to use this rule is to consider a population with a mean of 100 and a standard deviation of 10. Between what two values will 68, 95, and 99.7% of the data fall? The way we answer that question is by first drawing the distribution and placing the mean of 100 in the middle. Then we increment by the standard deviation of 10 in either direction until we have three values above and three values below the mean. So 100 plus 10 is 110, plus another 10 is 120, plus 10 again is 130. For values below the mean, we have 100 minus 10, which is equal to 90, minus another 10 is 80, and then minus 10 again is 70. Now we are ready to answer the question. Here is the empirical rule in case you forgot it. 68% of the data should fall within one standard deviation of the mean. Which values represent one standard deviation from the mean? Well, one standard deviation above the mean of 100 is this value here, 110, and one standard deviation below the mean is 90. So about 68% of the data falls between 90 and 110. We can use the same idea for 2 and 3 standard deviations from the mean. About 95% of the data falls between 80 and 120, and about 99.7% of the data falls between 70 and 130. This is the most basic application of the empirical rule, and it will always work as long as the distribution is normal. Place the mean in the middle and increment by the standard deviation 3 values to the right and 3 values to the left of the mean. Now, we can use the empirical rule to solve for a few different percentages. You may notice that if we split the distribution up based on 3 standard deviations above and below the mean, we actually have 8 different slices, which all carry their own percentage of data. We can use the idea of the empirical rule to solve for the percentage of data in each of these slices, and then use them to answer slightly more complicated questions. We already know from the empirical rule that 68% of the data falls within one standard deviation of the mean. So the two inner slices together represent 68% of the total data. But one fact that we already stated about the normal distribution is that it is symmetrical, meaning that each slice on the left has a corresponding equal slice on the right. So these two slices are equal, and they add up to 68%. If they are equal, then that means that each of them individually is equal to 68% divided by 2, which is 34%. Next, we can use the idea that 95% of the data falls within two standard deviations of the mean to solve for these two areas. 95% actually contains 4 separate slices, the 2 in the middle that we already solved for, plus these 2 new slices we want to find. If we take 95% and subtract these 2 slices, we get 27% to split to the 2 slices between 1 and 2 standard deviations from the mean. 27% divided by 2 is equal to 13.5%, which needs to go into each of these slices. We can take the part of the empirical rule that says that 99.7% of the data falls within 3 standard deviations of the mean to solve for these two sections between 2 and 3 standard deviations from the mean. But 99.7% actually contains 6 different sections, 4 of which we already know the percentages for. So we subtract the sections we don't want, 99.7% minus 13.5% twice, minus 34% twice, which leaves us with 4.7% for these two sections. You could also recognize that these four sections are just 95% of the data, which we know from the empirical rule. So 99.7 minus 95% is also equal to 4.7%. 4.7% divided by the two sections is equal to 2.35%. The tails of the distribution make up the remaining percentage we need to get to 100%. 99.7% of the data is within 3 standard deviations of the mean, so that means that 0.3% is in these two tails, since 99.7% plus 0.3% is equal to 100%. 0.3% divided by 2 is equal to 0.15%, which is in each of the two tails. Now we have the 8 completed slices. We know the percentage of the data that falls into any of these 8 slices, which we can use to answer more complicated questions. For example, let's say that we have a normal distribution with a mean of 50 and a standard deviation of 5. The first thing you should do is to draw the distribution and label the appropriate values at 1, 2, and 3 standard deviations above and below the mean. So we have the mean of 50, which falls right in the middle, and then we can add 5 to get 55, plus 5 again, which is 60, and plus 5 one more time to get 65. 50 minus 5 is 45, minus 5 again is 40, and minus 5 again is 35. Now it's easy to answer any questions about the percentage of data that fall between any of these 7 numbers. For example, I might ask you what percentage of the data is greater than 55. The part of the distribution greater than 55 are these 3 sections, 13.5% plus 2.35% plus 0.15%, which is equal to 16. So about 16% of the data is greater than 55. What about between 35 and 60? Well, there are 5 sections between 35 and 60, which are 2.35% plus 13.5% plus 34% plus 34% again plus 13.5%, which is equal to 97.35%. Or you could realize that this is 2 standard deviations from the mean, which is 95%, plus this section, which is 2.35%. 95% plus 2.35% is also equal to 97.35%. If you have this picture handy with the 8 sections filled out, it will be very helpful when you complete problems relating to the empirical rule, rather than trying to derive this picture every time you need to solve a new problem. The empirical rule is useful, but it restricts us to talking about areas relating to exactly 1, 2, or 3 standard deviations from the mean. We will learn how to find the area between any 2 points on a normal distribution in a future video. Alright, my friends, we have finished our discussion of the empirical rule. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.